Hello friends, welcome back. Happy welcome to you. In the last session, we have seen trigonometric ratios of complementary angles. In this session, we will see trigonometric identities, derivations and some examples. We will also continue in next one or two videos also on the problems related to trigonometric identities. First, let us see how to derive the trigonometric identities. This is for 10th grade CBSE or ICSE. Let's take a simple triangle, rectangle triangle to be precise. Let us say that it is ABC, and let us say that this angle is equals to theta. Now in this scenario, we know that this is O, and this is A, and this is H, and we have SOHCA over. Let's write down first all the trigonometric ratios in terms of ABC. So I will write down here sin theta, cos theta, tan theta, cosecant theta, secant theta, cot theta. Sin theta is opposite by hypotenuse, so I can say AB by AC. Then immediately we know cosecant theta is AC by AB. Similarly, cos theta is adjacent by hypotenuse, so I can say BC by AC. Its reciprocal secant theta will be AC by BC. Tan theta is opposite by adjacent, so it will be AB divided by BC, and cot theta will be reciprocal of that, that will be BC divided by AB. So we got all the trigonometric ratios in terms of theta. Now how to derive the identities? For that we will use Pythagoras theorem, and we will say that AC square equals to AB square plus BC square. We'll write it 3 times so that we derive 3 of the identities. AC square equals to AB square plus BC square. AC square equals to AB square plus BC square. In the first time, we will divide by AC square. Divide by AC square, we will get AC square by AC square equals to AB square by AC square plus BC square divided by AC square. AC square by AC square will be 1 equals to AB by AC. Where is our AB by AC? Here. Sin theta whole square, that is sin square theta, plus BC by AC whole square. BC by AC whole square is here. That is cos square theta. So our first identity is sin square theta plus cos square theta equals to 1. Let's go to the next identity. To do this, what we will do? We will divide by AB square, both left hand side and right hand side. So we will have AC square divided by AB square equals to AB square divided by AB square plus BC square divided by AB square. What is AC by AB? AC by AB is cosecant theta. So cosec square theta equals to AB square by AB square is 1. BC by AB, BC by AB, that is cot theta. So that will be cosecant square equals to 1 plus cot square theta. That is our second identity. So we got first identity, sin square theta plus cos square theta is 1. And we got the second identity, cosecant square theta is 1 plus cot square theta. Now we divided with AC square, we divided with AB square. What is left out is BC square. So let us divide by BC square and see what happens. We will have AC square divided by BC square equals to AB square divided by BC square plus BC square divided by BC square. AC by BC, that is nothing but secant theta. So square it up. Secant square theta equals to AB by BC, that is tan theta. Square it up. It will be tan square theta plus BC square by BC square is 1. So we got three identities, trigonometric identities. First one is sin square theta plus cos square theta is 1. Second one is secant square theta equals to 1 plus tan square theta. And the third one is cosecant square theta equals to 1 plus cot square theta. Now how can we write these identities a little bit into more other versions so that when you solve the problems you can easily do the transformation or you can convert them easily. So let's go ahead and write down first identity what we have found out, or we derived is sin square theta plus cos square theta equals to 1. Now I can write this in two ways. One, I can say sin square theta equals to 1 minus cos square theta, and that will give me sin square theta equals to 1 minus cos theta into 1 plus cos theta. So when you are solving a problem, you see like 1 minus cos theta. Immediately you know that I have to multiply with 1 plus cos theta, then I will get sin square theta. Similarly, I can also write down cos square theta equals to 1 minus sin square theta. That will give that cos square theta equals to 1 minus sin theta into 1 plus sin theta. So when you are solving a problem, suppose you have on the left hand side 1 plus sin theta, right side you see cos theta, then you know that, oh, I have to multiply with 1 minus sin theta, both numerator and denominator. Then I will convert them into cos. Now, the next identity we have is secant square theta equals to 1 plus tan square theta. We can write this as secant square theta minus tan square theta equals to 1. That means we can write down secant theta minus tan theta equals to 1 by secant theta plus tan theta. How we got that? Because a square minus b square is 1. We can write down a minus b into a plus b equals to 1. So secant theta minus tan theta into secant theta plus tan theta equals to 1. Similarly, we can go to the last identity, which is cosec square theta equals to 1 plus cot square theta. We can write it as cosecant square theta minus cot square theta equals to 1. That means, again, a square minus b square, we can write it as a minus b into a plus b. Cosec theta minus cot theta into cosec theta plus cot theta equals to 1, or we can say that cosec theta minus cot theta equals to 1 by cosecant theta plus cot theta. When we say that, we can take it in reverse also. We can say cosecant theta plus cot theta is 1 by cosecant theta minus cot theta also. Now, with this combined with our other identities, not identities actually, other formulas, whatever we have, something like we know that sin theta into cosec theta equals to 1, cos theta into secant theta equals to 1, tan theta into cot theta equals to 1, and we also have sin theta by cos theta is tan theta and cos theta by sin theta is cot theta. If you remember all this, then it's easy to solve these problems related to this particular exercise. Now, let's go to the next page and see what are the things we have to consider or keep it in our mind when we are solving problems related to trigonometric identities. There are some unspoken rules which you follow, it will help you. The first thing is, most of the problems at 10th class level can be solved by converting them into sin and cos. So when they are asking you to prove LHS is equals to RHS, if the LHS left hand side is not in terms of sin and cos, please convert them into sin and cos. So first rule is converting into sin and cos. Converting into sin and cos. What is the meaning of that? Meaning is, if you have secant theta, write it as 1 by cos theta. 95% of times the problems can be solved by converting them into sin and cos. But one or two problems will be there where you have to expand or you have to use either identities to solve the problem in a simpler manner. So 95% times we can do this. Secant theta is 1 by cos theta. Cosecant theta, you write it as 1 by sin theta. If you have tan theta, you write it as sin theta by cos theta. By doing this, what are we doing is, we are limiting the identity to one identity, sin square theta plus cos square theta is 1, because we are converting into sin and cos. This is the first rule, that convert them into sin and cos if they are not in sin and cos. That means they are like secant theta plus tan theta or cosecant theta minus cot theta. Then convert them into sin and cos. That is the first rule, converting into sin and cos. The second rule is always never multiply the denominators. Never multiply the denominators. Just before doing that, never multiply the denominator or never work on the denominators. Leave the denominator like that. Denominator में whatever is there, you just don't multiply them. Instead of that, look at your right hand side and see, most of the times whatever you have in the denominator will get cancelled out, or part of it will be cancelled by the end of the problem. So never work on the denominator, never multiply, like you have cos theta into cos theta minus sin theta. Don't write down cos square theta minus cos theta sin theta and also work on the numerator. Work on the numerator, see can you get cos theta minus sin theta as a factor, then you can cancel it, or you get cos theta as a factor. So you have to work on the numerator more, not on the denominator. So that you have to remember. So these things if you remember, then solving the problems will be very, very easy. Now let's look at some simple examples and try to solve them. Let me get R.S. Agarwal. Any book we can take. I have R.S. Agarwal, R.D. Sharma, S. Chand, we have Arihant. Any book we can take. We will do some simple problems from here. This should be a old book. Let us do some problems where we are converting them into sin and cos and solving them, so that you will understand this. This problem was asked in 2005, 2007, 2008. And it should be there in your some of the textbooks also, maybe in NCERT, I am not sure, but I'll write down 1 plus cot theta minus cosecant theta, and that you multiply with 1 plus tan theta plus secant theta equals to 2. Now you can see that on the right hand side we have 2 and on the left hand side we have trigonometric ratios, but none of them are in terms of sin and cos. In that scenario, what I told you, I said that you convert them into sin and cos, because then we can limit it to one identity, that sin square theta plus cos square theta equals to 1. So let's write down this. So what we will do, we'll keep 1 as it is. This cot theta, as I said, we will write it as cos theta by sin theta. Cosecant theta is 1 by sin theta. and multiply with 1 plus tan theta can be written as sin theta by cos theta plus secant theta is 1 by cos theta. Now this is what we need to prove equal to 2. So we started with LHS. Now let us take LCM here. We will get sin theta and this will become sin theta plus cos theta minus 1, and that I have to multiply with 2. If you take LCM here, it will be 1 by 1, so I will get cos theta plus sin theta plus 1 divided by cos theta. Now, if you observe, this is like a minus b multiplied with a plus b. You can see that, right? So I can write it as sin theta plus cos theta whole square minus 1 square. A plus b into a minus b is a square minus b square divided by sin theta cos theta. Now we know the identity a plus b whole square is a square plus 2ab plus b square. So I can write up sin square theta plus cos square theta plus 2 sin theta cos theta minus 1 divided by sin theta cos theta. Now we know that sin square theta plus cos square theta is 1. So this whole thing will be 1 and 1 will cancel. You get 1 plus 2 sin theta cos theta minus 1 divided by sin theta cos theta. Now 1 and 1 will cancel. Left out is 2 sin theta cos theta by sin theta cos theta. 2 sin theta cos theta divided by sin theta cos theta. Sin theta cos theta will cancel. Left out is 2. So we have seen one example where the given problem is not in terms of sin and cos. We converted them into sin and cos. We worked on the LHS. We got the right hand side. So most of the 10th grade problems, you convert them into sin and cos and try to get left hand side. If you are not getting right hand side, leave it there. Go to the right hand side, convert that into sin and cos and see like left hand side, right hand side, both of them are equal or not. That way you can do that. What we are saying is you have LHS, you have RHS. You are unable to go from here to here. That's not possible. That's okay. You just be here. And from RHS also you come here and prove that both of them are equal to x. LHS is x, RHS is x. Then I can say LHS is equals to RHS. Hope this problem is clear. Let's do one more problem. Now look at this problem. We have cos theta divided by 1 minus tan theta plus sin theta divided by 1 minus cot theta, and we need to prove that this is equals to cos theta plus sin theta. Now, the given problem on the left hand side is in terms of cos, sin, tan and cot, but the right hand side is in terms of cos and sin only. So what we will do, convert the left hand side also into sin and cos. So I will write down cos theta divided by 1 minus sin theta by cos theta plus sin theta divided by 1 minus cot theta can be written as cos theta by sin theta. When we go to the next step, we can write down cos theta divided by, take LCM here, we will get cos theta minus sin theta divided by cos theta plus sin theta divided by sin theta minus cos theta divided by sin theta. Now let us simplify that. We will take cos theta to there and sin theta to there. Then it will become cos square theta divided by cos theta minus sin theta plus sin square theta divided by sin theta minus cos theta. Now look at the RHS what we want. RHS we want cos theta plus sin theta. Looks like A plus B, and this is A minus B. This is A plus B, and this looks like A minus B. That means this guy should be A square minus B square. Correct? Now what is stopping that to become, because this is A minus B and this is B minus A. So let us take minus out and write down cos square theta divided by cos theta minus sin theta minus of sin square theta divided by cos theta minus sin theta. So what we have done, earlier sin theta minus cos theta is there with plus. We tried to make both the denominators the same. So we kept minus out and we got cos theta minus sin theta. So this will become cos square theta minus sin square theta divided by cos theta minus sin theta. Now as we discussed, we have A square minus B square. We need that, then only we will get A plus B. This is A minus B into A plus B divided by. Now you can see in these problems, whatever we did, never we touched on the denominator, even though we can multiply. I don't think so we got a chance to multiply in these examples, but examples where you can multiply also, don't multiply them. Just leave it like that. Answer is cos theta plus sin theta. So we understood how to derive the trigonometric identities and we solved a couple of simple problems. In the next section also we will continue with this. We will try to solve some simple problems, intermediate problems or some complicated problems. But 10th grade CBSE, generally the questions will be asked from the textbook. From the last exercise, in the 5th question, there are around 10 bits are there. From those bits only, the questions will be coming for 3 marks in the final exam. So if you are able to do those 10 bits, it will be very easy for you to score the marks there. But these are some examples which may or may not be from the NCERT. I just took them randomly, trying to explain you how we can convert them into sin and cos and solve them. We will continue this in the next session also. Thanks for your time and support. Bye for now.